Hello, and welcome to section 1.6, where we would be discussing other types of equations. So in 1.5, we discussed quadratic equations, and in 1.6, we'll be discussing some other types of equations. All right, so when we talk about polynomial equation, what we mean is an equation it's an equation that is of a standard form if one side is 0 and the other polynomial on the other side is in descending powers of the variable. For example, I have a polynomial such as 6x power 4 plus 3x cubed plus x squared plus 2x plus 1 is equal to 0. This is an example of a polynomial. And when we talk about the degree of a polynomial, it is the highest exponent of the variable. It is the highest exponent of the variable term. So, for example, if we look at there's the highest power of the variable x is 4. So the degree of the polynomial is equal to 4. Okay, so let's look at an example where we simplify a polynomial equation by factoring. So this will be our first example. We're looking at solving a polynomial equation by factoring. All right, so for example, if we have an equation, a polynomial equation 3x cubed plus 3 x squared is equal to 8x plus 12. If we have such an equation, the first thing is we have to write this in standard form. That means we have to group all the terms on one side and have 0 on the other side. So this will become 2x cubed plus 3x squared minus 8x minus 12 is equal to 0. So now it's in standard form. All right, so if we look at this standard form, we can see that the first two terms, 2x squared plus 3x squared, we can factor x squared out of it. We can factor x squared out of the first two terms, and this x squared out of 2x cubed leaves 2x here, and for the 3x squared, it leaves 3 here. And for the third and fourth terms, we can see that we can factor out -4 out of the third and fourth terms. So if you factor out -4, then we have 2x plus 3, and this equal to 0. So now we have 2x plus 3 2x plus 3. So we can factor 2x plus 3 out. So we can factor 2x plus 3 out. And we leave a remainder of x squared here minus 4 equal to 0. And from here, we can continue and solve for x from here. We know that either x squared minus 4 is equal to 0, or x squared or 2x plus 3 is equal to 0. So if we take x squared minus 4 equal to 0, x squared minus 4 equal to 0 is the same as x minus 2 times x plus 2. And so it's equal to 0. And so here we can have x is equal to positive 2 and x is equal to negative 2. And on the other hand, 2x plus 3 equal to 0. We have, if we subtract 3 on both sides, we have 2x is equal to negative 3 divided 2 on both sides. So we have x is equal to negative 3 divided by 2. So these three values will be our solution for x. All right, so let's look at some examples that involve radical equations. Let's look at radical equations. So let's look at radical equations, and let's use an example to explain radical equations. Okay, so example 2. Solve square root of x plus 3 x plus 3 and plus 3 is equal to x. All right, so in solving the radical, the polynomial equations that involve radicals, the key is to do on one side and all the other terms also on the other side. Then you square both sides to get rid of the radical. So for example, this, we can subtract 3 on both sides. So we will then have square root of x plus 3 is equal to x minus 3. And so at this point, we can square both sides. And so if we square both sides, square root of x plus 3 times of x plus 3 gives us x plus 3. And this is equal to x minus 3 squared, which when we expand will give us x squared minus 6x plus 9. All right, so now we can write this also in a standard form by grouping all the numbers and variables on one side. So if we do that, we'll have x squared minus 6x minus x plus 9 minus 3 is equal to 0. So we then have x squared minus 7x plus 6 is equal to 0. So we now have a quadratic equation from which we can solve for the values of x. And we can factorize this quadratic equation as x squared minus 6x minus minus we can factorize this quadratic equation as x squared minus 6x minus x plus 6 is equal to 0. So the 7x, negative 7x, you can write it as minus 6x minus x. And from here, we can factor these terms of the equation. We can factor, so for the first thing, we can factor x out. So if we factor x, we have x and x minus 6. And for the second parenthesis, we can factor negative 1 out. So negative 1, and we have x minus 6 is equal to 0. So this then gives us x minus 6 times x minus is equal to 0. And we know from the zero product principle, x minus 6 is equal to 0 implies x is equal to 6, and x minus 1 is equal to 0 implies x is equal to 1. All right, so after solving for the values of x, we will have to check whether either of these solutions makes the expression true or false in our final answer. So let's test the values for x to see whether they make the original problem true or false. All right, so if x is equal to 6, so if x is equal to 6, if we substitute x is equal to square root of x plus 3 plus 3 is equal to, we substitute 6 in here, we'll have square root of 6 plus 3, and plus 3 is equal to 6. So this is square root of 9 plus 3 is equal to 6. So this square root of 9 is 3, so this becomes 3 plus 3 is equal to 6. So 6 is equal to 6. So this expression is true. This expression is true. So that means x equal to 6 is a solution. Okay, let's test for the other solution, x is equal to 1. So if x is equal to 1, let's substitute it into the original equation again. Square root of x plus 3 plus 3, x, square root of x plus 3 is equal to x. All right, so now x is 3, x is 1. So let's substitute 1 in place of x. X is equal to 1. Let's substitute 1 in place of x and see what we get. So we get square root of 1 plus 3 is equal to 1. So this becomes square root of 1 plus 3, which is 4, plus 3 is equal to 1. Square root of 4 is 2. So we have 2 plus 3 equals to 1. So we have 5 is equal to 1, which is false. So from here, we can tell that the only solution is x is equal to 6. X is equal to 1. It's an extraneous solution. X is equal to 1. It's an extraneous solution. All right, so let's look at one more example that also involves radicals. So we call it example 2b. So for example 2b, we have, it also involves radicals. So we have square root of 3x plus 1 minus square root of x plus 4 equals to 1. So we have such an equation. We have such an equation, so let's try to solve this. Let's try to solve this other example. So to solve this example, similarly, we will group all the radicals on one side and all the other expressions also on the other side. Then we will try to square it. So here we would have square root of 3x plus 1 is equal to 1 plus the square root of x plus 4. And from here, we can square both sides. So if we square both sides, the left-hand side here becomes 3x plus 1, which is equal to, let's do this step by step. So the square of 1 plus square root of x plus 4 times 1 plus the square root of x plus 4. All right, so 3x plus 1 is equal to 1 times 1, which is 1, plus 1 times the square root of x plus 4 is the square root of x plus 4. Square root of x plus 4 times 1 is the square root of x plus 4. And the square root of x plus 4 times the square root of x plus 4 gives us x plus 4. And so from here, we have 3x plus 1 is equal to 1 plus 1 plus 4, which is 5, plus the square root of x plus 4 plus the square root of x plus 4 gives us 2 square root of x plus 4, and plus the x term here, which is here. Okay, so from and still try to simplify by grouping all the other terms on one side and the term that involves the radical on one side to take squares again. All right, so plus x, not 4. All right, so from here we can rewrite this as 3x minus x plus 1 minus 5 is equal to 2 square root of x plus 4. Okay, so this becomes 2x and 1 minus 5 becomes negative 4. It's equal to 2 square root of x plus 4. All right, so from here, we can square both sides, and that will give us 2x minus 4 squared is equal to 4x plus x plus 4. If we square this term, the 2 will be 4, and the square root sign will go away. So we get 2 times 4 plus x plus 4. All right, and the expansion of this 2x minus 4 will give us, if we expand 2x minus 4 squared, which is just 2x minus 4 times 2x minus 4 equal to 4 times x, or 4, let me just write 4x plus 4. So if we expand this, 2x times 2x is 4x squared minus 2x times 4, which is 8x, minus 4 times 2x minus 8x, minus 4 times minus 4, positive 16. And this equals to 4x plus 4. All right, so we can write this as 4x squared minus 8x is minus 16x, and plus 16 is equal to 4x plus 4. All right, so let's group every term on all the terms on one side. So we have 4x squared minus 16x minus 4x plus 16 minus 4 is equal to 0. So this gives us 4x squared minus 20x, 4x squared minus 20x, 4x squared plus 16 minus 4x minus 20x, and 4 and plus 4x squared minus 20x plus 12 plus 16 minus 4, which is 12, which is 12. Let me see whether I made a mistake anywhere along the line. So we started with, let's go back. Let's see how we started off with. So we started with 2x squared minus 4 squared is equal to 4x plus 4. Oh yeah, 4x plus 4. We made a mistake here. 4 times x plus 4. This is 16, not 4. Let me. So this is. So 4 times x is 4x plus 4 times 4 is 16. So that was not 4. So let me come here. So here is 4 plus 16. So this is 4 plus 16. And so we'll subtract 16 from here. And so we will have a 0 here. So plus 0 is equal to 0. So we have 4x squared minus 20x is equal to 0. So 4x squared minus 20x is equal to 0. So from here we can factorize 4x out of this. So we have 4x times x minus 5 is equal to 0. So that means 4x is equal to 0, which implies x is equal to 0, or x minus 5 is equal to 0, which implies x is equal to 5. So we have x is equal to 0 and x is equal to 5. So let's check which of these solutions are true and which is false. All right, so when x is equal to 0, then we have square root of 3x plus 1 minus square root of x plus 4 is equal to 1. All right, so if x is equal to 0, then we have square root of 3 times 0 is 0 plus 1 minus the square root of 0 plus 4 is equal to 1. All right, so square root of 0 plus 1 is 1. So this is square root of 1 minus square root of 4 is equal to 1. So square root of 1 is 1 minus the square root of 4 is 2. And this is equal to 1. This is, oh, excuse me, this is equal to, this is equal to 1 here. All right, so we can tell that 1 minus 2 is negative 1, and it's not equal to 1, right? So the solution x is equal to 0 is false. So this is false. Negative 1 equal to 1 is false. So we can tell that x is equal to 0 is an extraneous solution. So let's test for the other solution when x is equal to 5. X is equal to 5. So let's substitute into the original equation, which is 3x plus 1 minus the square root of x plus 4 is equal to 1. So when x is equal to 5, we have square root of 3 times 5 plus 1 minus the square root of 5 plus 4 is equal to 1. So this becomes the square root of 3 times 5 is 15 plus 1. So the square root of 16 minus the square root of 5 plus 4, which is 9, equals to 1. So square root of 16 is 4 minus square root of 9, which is 3, is equal to 1. So we can see that 4 minus 1 is 1, which is equal to 1. So this is true. So that means x is equal to 5 is the only solution. X is equal to 0 is an extraneous solution. All right, so this is another example that involves radicals. So now let's look at examples that involve rational exponents. So the next is equations with rational exponents. Equations with rational exponents. So some preliminaries before that. An equation with a rational exponent is uh, an equation of the form something like a power m divided by n. This is an equation with a rational exponent, and this is equal to this can be written the same thing as a power m times power 1 divided by n. And whenever you see power 1 divided by n, it's the same as the nth root. So this is the same as the nth root of a power m. All right. And two things, if m is even, then x power um, m divided by n, and we have, if m is even, and we have x power m divided by n is equal to k. We can rewrite this as x power m divided by n times power n divided by m, and this is equal to plus or minus a power n divided by m. So we multiply both sides, we raise both sides to the power n by m, and we do this so that this n will cancel this n, this m will cancel this n. So we have x is equal to plus or minus a power n divided by m. And when the m is even, that is the case when we have, that is when we use the plus or minus. If the m is even, that is where we use plus or minus. If the m is odd, if the power m is odd, if m is odd, then we don't need a plus or minus sign. So if m is odd, then we have x power m divided by n is equal to k. We can raise both sides the power n divided by m. So this is equal to k power n divided by m. So m cancels m, n cancels m. So we have x is equal to k power n divided by m. So this is for the case where m is odd. M is odd now. And when m is an even number, then we have the plus or minus case. All right, so let's look at some example to illustrate this point. Let's look at some examples. So example, let's call this example 4. So example 4. So example 4, it says solve 5 power x, 5 power, so 5 x power 3 divided by 2, 5x power 2 minus 25 is equal to 0. All right, so here let's add 25 side. So if we do that, then we have 5 power 5x power 3 divided by 2 is equal to 25. And from here, we can divide 5 on both sides. So to do that, we have x power divided by 2 is equal to 25 divided by 5, which is 5. All right, so now we can raise both sides to the power 2/3. And because m is odd, this is our m is odd. We have x power 3 divided by 2 times power 2 divided by 3 is equal to 5 power 2 divided by 3. M is odd. If the m was even, then we would have used plus or minus on the right-hand side. But m is odd, so we keep it as 5 power 2 divided by 3. And we multiply both third to up the x, or to make the power of the x 1. So 2 divides 2 divides 3. So we have x is equal to 5 power 2 divided by 3. And 5 divided by 3, we can write it as, is the same thing as 5 squared times power 1/3. 5 squared is also the same thing as 25. So this is the same 25 power 1/3. 1 divided by any, whenever we see the power 1 divided by any number, is the same as the nth root of that number. So this is the same thing as the cube root of 5. So x is equal to the cube root of 25. All right. So let's test whether this x value is actually a solution or not. So we have, so when x is equal to this, we have 5 times x, uh, 5 power 2/3. Cube root of 25 is the same thing as 5 power 2/3, and this time 3 divided by 2 minus 25 is equal to 0. So we have here 5 times 3 divides 3 once, 2 divides 2 once. We have so 5 times 5 minus 25 is equal to 0. So 25 minus 25 is equal to 0. So 0 is equal to 0 is true. So that means x is equal to uh, cube root of 25 is a solution. All right, so let's look at an example where the power of the power m is odd. So let's look at another example where the power is also, let's call it example 4b. So we have to solve x minus 1 power 2/3 is equal to 64. All right, so from here, we can raise both sides to the power 3 divided by 2. So we have x minus 1 power 2/3 times 3 divided by 2 is equal to plus or minus 64 power 3 divided by 2. And this is because the m is even now. The m is 2. The m is even. So we have plus or minus. All right. So from here, we got 2 divides 2 and 3 divides 3. So we end up with x minus 1 is equal to plus or minus 64 power 3 divided by 2. All right. And 64 can be written as h squared. So this is the same as x minus 1 is equal to plus or minus h squared times power 3 divided by 2. And this 2 divides this 2. So we have x minus 1 is equal to plus or minus 8 power 3. And 8 power 3 is 512. So we have this is equal to plus or minus 512. Okay, so we have x x is equal to 1 plus or minus 512. So that means x is equal to 1 plus 512, which gives us 513, and x is equal to 1 minus 512, which gives us 5 negative 511. All right, so we can test whether each of these solutions are correct or not. But so let's test when x is equal to, so when x is equal to 513, let's test the solution. When x is equal to 513, x is equal to 513, we will have 513 minus 1 power 2/3 is equal to 64. All right, so 513 minus 1 is 512 power 2/3 is equal to 64. All right, okay, so 512 is the same as 8 power 3. 512 is the same as 8 power 3. So 8 power 3 times 2/3 is equal to 64. All right, so this 3 cancels this 3. So we see that we have 8 squared is equal to 64. 8 squared is equal to 64. And 8 squared we know is 64. So 64 is equal to 64. So this is true. So that means x is equal to 512 is a true solution. Let's test for negative 511. So if x is equal to negative 511, we have negative 511 minus 1 power 2/3 is equal to 64. Okay, so 511 minus 1 is negative 512, so negative 512 power 2/3 is equal to 64. Negative 512 is the same as negative 8 to the power 3. So minus 8 power 3 times 2/3 power is equal to 64. So this 3 cancels this 3. So we have minus 8 squared is equal to 64. Minus 8 squared is 64. This is equal to 64. So x is equal to negative 512 is also a solution. So we have two solutions. X is equal to negative 512 and x is equal to 512. Okay, so now let's look at some equations that are of a quadratic form. Equations of a quadratic form. Let's look at some examples of equations of a quadratic form. All right, so let's use an example. So this will be our say solve. So in example 5, it says solve x power 4 plus 5x squared plus 6 is equal to 0. All right, so if we look at this equation, we will notice that if we will notice that x power 4 x power 4 x power 4 is the same as x squared times power 2 again. So if we so the key is to make a substitution for x squared. So if we let u be equal to x squared, then we can rewrite this equation as x squared would become u squared plus 5, and x squared is u. So u plus 6 is equal to 0. So we have now reduced the equation from the fourth power to a quadratic equation from which we can factorize. So we have this equation now, u squared plus 5u plus 6. Okay, so from here we can factorize this equation. So u squared plus 5u minus 6, we can rewrite it as u squared u squared plus 5x squared u squared plus 5u plus 6. We can rewrite this. I believe. Let me think. I need to make a correction in the equation. It was rather x squared x power 4 minus. It was a minus here, not a plus. So let me make a correction. So x power 4 minus 5x squared. So this becomes u squared minus 5u plus 6 is equal to 0. So now we can factorize this. We can rewrite this as u squared minus 5u, we can write 5u as 3u minus 2u plus 6. And if we do this, we can factorize out of this second parenthesis, and factorize also out of the third and fourth term. So we can factor u out of the this first parenthesis. So u times u minus 3, and we can factorize -2 out of the second parenthesis, so minus 2 times u minus 3. So now we have u minus 3, u minus 3. So we can do u minus 3 times u minus 2, and this all equal to 0. Okay, so from the zero product rule, we know that from here, u minus 3 is equal to 0 means u is equal to 3. And u minus 2 equal to 0 implies u is equal to 2. But u is not what we are looking for. What we are looking for is x. But we said at the beginning that let x squared be equal to u. So in place of u, we can now substitute back x squared. So we have, in the first case here, we have x squared is equal to 3. So that means x is equal to plus or minus square root of x is equal to plus or minus square root of 3. And we also said x squared, u is equal to 2 means x squared is equal to 2, which also implies x is equal to plus or minus square root of 2. So we have these 4 solutions for x. So we can test whether each of them makes the solution to be true or false. For example, let's test one of them. Let's say the first one. If x is equal to let's say the positive square root of 3. So we have, our equation is x power 4 minus 5x squared minus plus 6 is equal to 0. So here, if x is square root of 3, so we have the square root of 3 power 4 minus 5 times the square root of 3 squared plus 6 is equal to 0. So square root of 3 power 4, square root of 3 squared is equal to 3, right? So we have the square root of 3 squared times the square root of 3 squared. So we have 3 times 3, which equals to 9. So we have 9 minus 5 times the square root of 3 squared is 3, so minus 3 plus 6 is equal to 0. So 9 plus 5 is 15, minus 5 times 3, which is 15, is equal to 0. So 0 is equal to 0 is true. So x is equal to square root of 3 is a true solution. So we can test for the other values similarly. Let's look at examples that involve the absolute value, equations involving the absolute value. Equations involving the absolute value. Let's look for equations. So we looked at equations that are of quadratic form. Let's also look at equations that involve the absolute value. All right, so for example, so this will be our example 6. So if we are to solve absolute value of 2x minus 1 is equal to 5. All right, so in this case, we would have 2x minus 1 is equal to 5, or 2x minus 1 is equal to negative 5. So 2x minus 1 is equal to 5. If we add 1 on both sides, we have 2x is equal to 5 plus 1, which is 6. And if we divide both sides by 2, then we have x is equal to 3. And on this side, if we add 1 on both sides, we have 2x is equal to negative 5 plus 1, which is negative 4. We divide here by 2, divide both sides by 2. So we have x is equal to negative 2. So the solution set, is um, negative 2 and 3. So that would be our solution set. All right, so let's look at another example. Um, let's look at another example where we use let's look at another example where we use the quadratic substitution, just like what we did in the previous example. So let's go back and look at a similar example on the previous one where we did the uh, quadratic equations that are of the quadratic form. So we'll call this example 5b. So this will be our example 5b, and we are to solve x plus 5, x plus 5 squared plus 12 times x plus 5 plus 35 is equal to 0. So for this, we have x plus 5 all squared, x plus 12 times x plus 5. So for this, we can say let u be equal to x plus 5. So if we do that, then we can simplify this equation to be u squared plus 12u plus 35 is equal to 0. So this becomes a quadratic equation that we can factorize. So we can write the 12u as 7u plus 5u. So we can write this as u squared plus 7u plus 5u plus 35 is equal to 0. And so now we can factorize these two. So we can factorize, so we have u times u plus 7 plus 5 times u plus 7 is equal to 0. So we can factorize u plus 7 now. So u plus 7 times u plus 5 equal to 0. So that means u plus 7 is equal to 0, means u is equal to negative 7, and u plus 5 equal to 0 implies u is equal to negative 5. but we said u is x plus 5. So this means x plus 5 is equal to -7, which means if we subtract 5 from both sides, x is equal to -12. And we also said x, we also have, in the second one, I equal to -5. We substitute back x plus 5 in place of u. So we have x plus 5 is equal to -5. So which means if we add 5, if we subtract 5 from both sides, we have x is equal to x is equal to -10. And we can test whether these solutions are true or not by substituting back um, the x values in the original equation. So for example, let's test for the first one. When x is equal to -12, we will have -12 plus 5 squared plus 12 times -12 plus 5 plus 35 is equal to 0. So -12 plus 5 is -7. So we have -7 squared plus 12 times -7 plus 35 is equal to 0. So -7 squared is 49 minus 12 times -7 is -84 plus 35 is equal to 0. So 49 plus 35 is 84. So 84 minus 84 is equal to 0. So 0 is equal to 0 is true. So this solution, x is equal to -12, is true. All right, so let's look at the last example, which is of an application form. So we will call it example 7. We'll call it example 7, which is an application. Okay, so it says the application problem says the h is equal to minus 2.3 square root of I plus 67.6 models weekly. For this weekly television viewing. Weekly television viewing. Television viewing time in hours. In hours by annual income are in thousands of dollars. Annual income in thousands of dollars. What annual income corresponds to 33.1 hours per week. a week of TV watching. All right, so we are told the relationship between television watching in hours and income is age is equal to minus 2.3 square root of I. All right, so this is an plus 67.6. So this is an equation of the radical form. So the first thing that we do is to group all terms except the radical on one side, then we square both sides. All right, so in the question, we are given that h is equal to 33.1. The number of hours, 33.1, is being given, and we are asked to estimate the annual income based on that. So h is 33.1, so we have 33.1 is equal to negative 2.3 square root of I plus 67.6. So if you subtract 67.6 on both sides, then we have 33.1 minus 66.6, which is equal to negative 34.5, and this equals to negative 2.3 square root of I. All right, so at this point, we can divide both sides by negative 2.3. And so if we do that, and we have square root of I is equal to 15. And from we can square both sides, so square root of I squared is equal to 15 squared. So square root of I squared is I, so that's equal to 15 squared, which is 225. All income of 200,000 corresponds to 33.1 hours a week. All right, so this will be all for today, and continue with the section 1.7 next time.